Listen, people, is the vector dot product. How to apply this vector dot product for the vectors which are on this OXY Cartesian coordinate plane. Right. First of all, people will see we have learned that the unit vectors along positive x-axis and positive y-axis are simple I vector and simple j vector respectively. I mean this, when I consider this way, people, the y-axis and this way our x-axis, along this direction the unit vector is I and here it is j. This is the origin, no? You know this, okay? And in the negative x direction, it is minus I. Negative y direction, it is minus j, the unit vectors, okay? Right. Now, when I consider, people, this way, I dot I, j dot j, yeah, you know, dot product we defined, a dot b we define, people, like this, no? A dot b we define to be modulus of a times modulus of b into cos theta, where this theta is the angle between vectors a and b. You know this, right? You know this. Now, when we apply this definition a dot b for this I dot I, then you know this is I modulus, again I modulus, and cos 0, no? Because between I and I, the angle is 0, right? Then modulus of I is a unit vector, no? I is a unit vector, so then its modulus is 1, people, right? So then this is 1 multiplied by, this is 1 multiplied by cos 0 also 1. So then this is nothing but 1, okay? Then secondly, j dot j, in the same way we can define j modulus cos, again between j and j, the angle is 0, people, huh? Then cos 0 we get, and here j modulus 1, because j is the unit vector, right? J modulus 1, cos 0 also 1, therefore this product is 1. Understood right now? Right. Now, next one, I dot j. I dot j. You can write I modulus, j modulus. People, between I and j, what is the angle? I is along this direction, j is along this direction. The angle between them is 90. Then we have to put there, people, cos 90. Cos 90. I modulus, I is a unit vector, therefore its size is 1, right? Then 1 multiplied by 1, j modulus also 1, cos 90 is 0, people. Cos 90 is 0. So therefore, 1 multiplied by 0 means the product is 0. So therefore, I dot j is 0. You know, people, I dot j, this order when we interchange, I dot j is equal to j dot I, because j dot I, because we have said, people, a dot b is equal to b dot a. We said this, no, and we proved, no. So once we interchange this order of the vectors in taking the dot product, answer won't change. So therefore, if I dot j is 0, then j dot I also 0. Understood? So therefore, this j dot I is equal to I dot j, and this is therefore 0. Understood? Right? Now, what you have to understand from here, people, whenever we consider vectors in OXY Cartesian coordinate plane, along x-axis the unit vector is I, along y-axis the unit vector is j. This says, people, when you take dot product between the same vectors I and I, j and j, here I dot I is 1, j dot j is also 1. Then we take the dot product between two different unit vectors I and j. The I dot j or j dot I both equal to 0. Right? Now, suppose people here, when I consider this way a point P on the Cartesian coordinate plane with coordinates xy, suppose. Right, I'll take x1 and y1 as the coordinates of point P, right? Point P having the coordinates x1, y1. Suppose this is that point, huh? Then OP we can really find. And suppose we have another point Q called with coordinates x2, y2, then we have OQ like this, huh? Okay, right. Now, people, you can write this OP vector. OP vector you can write. We can write OP vector and this OQ vector. OP vector. Tell me how to write this OP vector. OP vector means the position vector of the point P. No? Position vector of the point P is this OP vector. How to write that one, people? We said what? X coordinate times I plus y coordinate times j is the way of writing the position vector of a point. Understood? So therefore, OP vector we can write x1i plus y1j. Similarly, OQ vector we can write, people, x2i plus y2j. I think you can understand this very well because we have done this now. Right. Now, in addition to that, people, OP modulus. OP modulus. How to find OP modulus? Yeah, when we have a vector having I and j, that occasion we said how to find the modulus. We said, people, it is the square root of what? It is the square root of I coefficient perfect squared plus j coefficient perfect squared this way. And OQ modulus is the square root of x2 squared plus y2 squared. Right. Now we can write this way, people. OP vector dot OQ vector. We can write OP vector dot OQ vector. We can write OP vector dot OQ vector. When we write according to the definition of A dot B, how to write this, people? OP vector modulus multiplied by OQ vector modulus. If I take the angle between OP and OQ as theta, we can write this as cos theta. Okay. OP vector modulus is the square root of x1 squared plus y1 squared, and OQ vector modulus is x2 squared plus y2 squared cos theta. Right. I think up to here you can very easily understand. Right. So let us keep this as number 1. I directly applied, people, the vector dot product. Okay. Directly applied the vector dot product for the vectors OP and OQ. That's all. Right. Now this OP dot OQ, I am going to find, people, in another way. That is the using the distributive law property. Yeah. OP vector dot OQ vector. I can now write, people, OP vector is this, no? x1i plus y1j dot OQ vector x2i plus y2j. Right? Now you know how to use the distributive law. How to use that, people? We take this x1i Using that, we remove this second bracket. That means this dot. There, how to do this, people? Yeah. X1 and X2, first we have to multiply because this X1 and X2 are two numbers, no? Right. X1, X2 and I dot I. People know X1, X2 are two real numbers. We never take the dot product between two numbers, no? Numbers means scalars, no? To take the dot product, people, we should have two vectors. Here, X1 and X2 are two real numbers, like 2, 3, 5, 6, and so on. Such two real numbers are this X1 and X2. So therefore, when we have to take the dot product, for example, 2i vector dot 3i vector, when we have to take dot product like this, people, first of all, this 2 and this 3 we have to multiply as 6. Then we have to take I dot I. This is how we take the dot product of two vectors having I or j with real numbers. Understood? Okay. So now here what we do is this way. X1 and X2 we multiply and I dot I we have, right? So we have to write I dot I. Okay. Secondly, this and this. This is plus, this is also plus. Plus into plus is plus, people, right? Now, X1, Y2 we have to multiply. X1 and Y2 because X1 and Y2 are two real numbers. And I dot J. We have to take. Right? Now, secondly, these people using this Y1J, we have to take the dot product with this and this both. Now, let's see how to take that. Here plus, then the sign is plus. Y1, X2. That means X2, Y1. And now here J dot I, people. J dot I. J dot I. Right? And next one here, this one and this one. Y1, Y2 product. Y1, Y2 product, J dot J. This way I can write. Okay. Now, a short while ago we said I dot I. What's that? I dot I is 1. We showed that. No? This is 1. I dot J, we proved, people, this is 0. J dot I also 0. J dot J is what, people? 1. Okay. Now what do you get here? X1, X2 into 1 means X1, X2. This is 0, therefore this product is 0. This is 0, therefore the product is 0. Here Y1, Y2 into 1 means Y1, Y2. This is really, people, we get for what? OP vector dot OQ vector. Understood? So now, this way only we use to take the dot product between these two vectors. But people, very easily you can remember, in this case, by observing this answer and this dot product, here X1, X2 is the product of the coefficients of I. Here I coefficient is X1, in this bracket I coefficient is X2. Then this is X1, X2 means product of the I coefficients. And Y1, Y2 is what, people? Product of the J coefficients. So therefore, hereinafter, when we need to take the dot product between two vectors which are expressed in IJ form, people, very easily we can take those answers. How? Multiply I coefficients X1, X2 and add, multiplying this J coefficients Y1, Y2. That's all. Why? Other I dot J and J dot I become 0, no? So therefore, people, that's how we take that answer. So now what I do is, people, this is number 2. This is number 2. Then in number 2 left hand side, what we have is OP dot OQ. Number 1 left hand side also, people, we have OP dot OQ. The same vector. Left hand sides we have. Then the right hand sides must be equal. So then we can equate this 1 and 2, right? Once we equate, people, this 1 and 2, what we get is 1 equals to 2. Then we can write this way. This right hand side and this right hand side must be equal. This says us x1 squared plus y1 squared root times x2 squared plus y2 squared root into cos theta is equal to this, right? x1, x2 plus y1, y2. Then, people, we can subject this cos theta, right? Cos theta can then be subjected by this. Cos theta is equal to x1, x2 plus y1, y2 divided by the square root of x1 squared plus y1 squared times square root of x2 squared plus y2 squared. This way we can find the cos theta, and theta can be subjected. Theta is equal to cos inverse, the same part, this will be coming here. That way, people, we can find the angle between two vectors which are on the OXY Cartesian coordinate plane. So that is another application of dot product in OXY Cartesian coordinate plane, right? From these, people, questions available in past papers. So therefore, this is also another important part in the same lesson. Okay. So therefore, we'll write down these notes. Okay. Right. Write down today heading as, people. Right. Write down today heading. I will write the heading as this way. Right. Dot product for the vectors in OXY plane. Right? Yeah. Right. Now we'll write, people, this way. Right. Now we can consider this way. Don't draw this one yet. All right. We have the time to write. Draw that one. We'll consider this way. This is the positive x-axis, I. This is j. Negative x-axis minus I. Negative y-axis minus j. Here O. Right. Okay. Right. Rather than this, consider the unit vectors. Consider the unit vectors. Simple I vector, underline simple I, and simple j vector, underline simple j. Along the x, along the capital X and capital Y, along the capital X and capital Y axis, respectively in OXY Cartesian coordinate plane, in OXY Cartesian coordinate plane. Right. You will draw this small diagram. Draw this small diagram. Right. After drawing this, we'll first write I vector dot I vector. Then how to define these people? I vector modulus times J vector modulus into not I vector modulus into I vector modulus, because I dot I we consider now. Between I and I, the angle is 0, therefore cos 0 we get. Right. I is the unit vector along x-axis, so therefore its modulus is 1, no? So therefore this is 1. 1 multiplied by this also 1, cos 0 also 1, this is 1. Then I dot I is 1, right? Right. Now secondly we can write J dot J. Similarly, we can write that one, but we'll write this one. J modulus times cos 0. J modulus is 1 multiplied by J modulus is 1 multiplied by cos 0 is 1. This is also 1. J dot J. It's also 1. Okay. Now we'll write I dot J. Now we'll write I dot J. We'll write I dot J. I dot J. What is that, people? I modulus times J modulus cos 90. You know, between I is this vector, no? J is this vector. Angle between them is 90, right? Cos 90. Cos 90 is 0. I vector modulus is 1. J vector modulus also 1. Cos 90 is 0. This is 0. So therefore, I dot J is 0, right? Since J dot I is equal to I dot J, J dot I is also 0. Right. So therefore, as a rule, you can remember, people, when you take the dot product between I, between J, answer is 1. But when we consider the dot product between I and J, whichever the order, it is 0. We have to remember that. Right. J dot I dot J, 0. Right. Then this is the first thing that we need to consider here. Right. Right. Now we'll write, people, this way. Another subheading, not subheading, we'll write one sentence like this. Write down like this. Consider the points consider the points P x1 comma y1 and Q x2 comma y2 on the OXY plane. On the OXY plane. Right, people, draw this diagram. Draw this diagram, people. Right. Right now, yes. Now we'll write, people, this way the next note. Right. First we'll write OP vector. First we'll write, people, OP vector. And this OQ vector. OP vector and OQ vector. You can write OP vector x1i plus y1j. OQ vector x2i plus y2j. This is okay, no? We have learned that when we are given the coordinates of the point, we know how to write the position vector of that point. We learned that before. Right. Now, not only that, when a vector is expressed in ij form, we know how to write its modulus 2. So what is the modulus of the vector OP? It is I coefficient perfect squared plus j coefficient perfect squared root. And people, this one, OQ vector modulus is going to be x2 squared plus y2 squared root. Now I can write this way, OP vector dot OQ vector dot product. It is now OP vector modulus times OQ vector modulus times cos theta. Theta is the angle between OP and OQ. Right. I will keep, people, substituting this OP and OQ modulus like this. OP vector modulus is going to be x1 squared plus y1 squared root. OQ vector modulus is going to be x2 squared plus y2 squared root into cos theta. OP vector dot OQ vector. Let us take this one, people, number 1. Then we can write OP vector dot OQ vector in another way. How? It is substituting for OP vector x1i plus y1j dot x2i plus y2j. Now OP vector dot OQ vector. Right. We take this and this. The dot product. What's that, people? x1 and x2 we multiply. I dot I coming. This one and this one now. x1 y2 I dot j. Next one, using this y1 x2, that means x2 y1. x2 y1 j dot I plus, what's next, people? y1 y2 j dot j, j dot j. Right, people, we know I dot I just now we found it is equal to 1. I dot j equals 0. This also j dot I becomes 0. J dot j is 1. Then these two terms will be 0. Then what we get to the right hand side, people, this x1 x2 plus over there y1 y2. Right? This is OP dot OQ. OP dot OQ. Right. So now this is number 2. So therefore, remember, when we need to take the dot product between two vectors which are available in IJ form, the dot product going to be product of the I coefficients. x1, x2 come in, multiply this I coefficients plus product of the j coefficients. Right? This way. Now in number 1 left hand side and number 2 left hand side, the same thing available. Therefore, the right hand side must be equal. Then write down 1 equals to 2. 1 equals to 2. Right? Yeah. So now once we equate the right hand sides of this 1 and 2, what we get is, people, this one should be equal to this one. Right? This one should be equal to this. Right? Right, people, now equate them. Okay, now equate this 1 and 2. When we equate this 1 and 2, this is equal to this, right? Then we can write, people, this way. Then you can write this one, the root of x1 squared plus y1 squared times x2 squared plus y2 squared root cos theta is equal to this one, x1 x2 plus y1 y2. Then cos theta can be subjected x1 x2 plus y1 y2 divided by this 2, right? x1 squared plus y1 squared into x2 squared plus y2 squared. Okay. Then you can subject theta by this. Theta is equal to cos inverse x1, x2 plus y1, y2 divided by this way. This way we can find the angle between the two vectors OP and OQ, right? Right, we'll see to do some questions under this. Okay. People take your tutorial PDF available. Yeah. We'll take question number 66. Question number 66, right? Question number 66. Now, people, that question is question number 66. It says point A 1, 2, point B 3, 3, and point C 2, 5. Right. Here, I'll roughly mark the points on the XY plane. This x-axis, y-axis. Along this y-axis, the unit vector is j. Here, I. Okay, now point A is 1, 2. A is somewhere here, suppose. A 1, 2. B 3, 3. 3 somewhere here. I'll take B somewhere here, 3, 3, A somewhere here, 5. Point C 2, 5. Yeah, 2, 5 is somewhere here, no, people? C 2, 5. These are the 3 points given us. Okay. Okay. Be the vertices of a triangle. Find the position vectors of ABC points. Right. Position vector of the point capital A mean people OA vector. That of B is OB vector. That of C is OC vector. Okay. Then OA vector you can write. Question number 65. No. OA vector we can write people 66. No. Right. OA vector you can write how? 1 times I plus 2 times j. I plus 2j. And OB vector? It's 3i plus 3j. And OC vector? 2i plus 5j. 2i plus 5j. This way we can write the position vectors. You know the position vectors means this starting from the origin and ending at that point. That vector only called as people what? The position vector of that point. Right. That you know. And what is next people asking? Find AB and AC vectors. AB vector. Right. AB vector we need. AB vector means people this vector, no? A to B vector is no. How to write AB vector? AB vector you can write ending point position vector minus starting point position vector. Ending point is B no here. Then OB is the position vector of B minus OA. AB vector is equal to OB vector is this 3i plus 3j minus OA vector I plus 2j. 3i minus I is people 2i. 3j minus 2j is it's people j, no? It's j. This is our AB vector. Right. What is secondly asking? Secondly, it is asking. It's asking AC vector people, right? AC vector. AC vector means the vector from A to C, no, this vector asking, right? Right. AC vector outright. Second letter position vector. It is C, no? Or C vector. 2i plus 5j minus A I plus 2j. 2i minus I, it's people I. 5j minus 2j, it's 3j. This is AC vector. Right? That we found. Asking and length of the sides AB and AC. People, this AB length, this length, and this AC length. People, AB length and AC length mean the modulus of that AB vector and AC vector, right? Then AB length we can write how, people? AB length is equal to AB vector modulus. And you know, modulus of a vector which is expressed in IJ form. How to write, people? I coefficient squared plus j coefficient here 1, its perfect squared root. This is nothing but root 5. Then AB length is root 5. AB length is nothing but AB modulus, right? Okay. And AC length also we can write. AC length is equal to AC vector modulus. AC vector is I plus 3j. It is 1 squared plus 3 squared root. Then AC length going to be root 10. That also be completed. Hence, find the angle between AB and AC vector. AB vector is people this. A to B vector is this. A to C vector is this. Let us take this angle as theta. Then ask him to find this theta. Then what we do, people? Right. We can write like this. We can start writing this way: AB vector dot AC vector. People, AB vector dot AC vector, how to define the vector dot product between two vectors? First vector modulus times second vector modulus times cos theta. Right. Now what I do is, people, for the AB vector and AC vector, I substitute in this IJ form. For the AB vector, I am going to do substitute what, people? 2i plus j. dot. A C vector, it is I plus 3j. Correct, no? AB vector is 2i plus j. AC vector I plus 3j. Okay, right. Now AB vector modulus is going to be this AB length root 5, AC root 10 cos theta. And I can take the vector dot product between these two vectors. You can very clearly see here, this vector having ij, this vector also having ij. You know how to take a dot product between two vectors which are available in ij form. I told you the method of getting that. What we do, the I coefficients we have to multiply, the j coefficients you have to multiply. 2 into here we have 1, no? 2 into 1 is 2, plus here 1 into 3, it's 3. That's what we get. Is equal to people root 5, root 10 cos theta. Then you can substitute cos theta by dividing this product. Okay. And write cos theta is equal to 2 plus 3 is it's 5 divided by root 5 times root 10. Okay, people. This one you can write this way, cos theta is equal to this 5 at the numerator we can write as root 5 into root 5 divided by root 5 into root 10. This way you can write. Okay. This way you can write. 5 you can write as root 5 into root 5. Then you can cancel down this root 5 with this. Even how to write root 10? Root 10 you can write this way. 5 into 2. This is the way of writing. 5 multiplied by 2 is the way of writing this 10. Since the root is available there, apply root for this and this both. Root 5, root 2, like this we can write root 10. Now this root 5 and this root 5 we can again cancel down. We have 1 at the numerator, root 2 at the denominator. Then what do you have, people? Cos theta. Cos theta is 1 over root 2. People, if cos theta is 1 over root 2, what is theta? Theta is 45, no? For the angle 45 only, cos becomes 1 over root 2. Understood? Okay. So then we get, people, here, this gives us theta equals 45 degrees. So what is theta? The angle between AB and AC. So then you can write, therefore the angle between AB and AC is 45 degrees. Understood? Write down then. Write down. Therefore the angle between AB and AC is 45 degrees. Right. People will take the next question as 67. Next one take as 67. Right? Take 67 as next. Take 67. Right. Read the question of 67. That question says something like this. If the dot product of a vector with the vectors minus I plus j and the other vector is 4i plus 3j are 1 and 17 respectively. Find the vector. See the question, people. there is a vector. That vector and this vector, we take dot product. The answer is 1. And the same vector and this vector we take dot product. The answer is 17. Then ask him to find what? That vector. Yeah. People, we assume that vector like this. Let the vector be the vector. Let the vector be xi plus yj. Xi plus yj. You know this x and y are two real numbers, no? Where x comma y are real numbers. This way we have to assume. Then in order to know the vector, we should find this x and this y, the two real numbers x and y we have to find. Then we know that vector. Now we are given people this way. When you take the dot product of this vector and this vector, that means this, no? Xi plus yj dot this minus I plus j. The dot product of this vector and this vector. People given us the answer as 1. This is 1. Now how to simplify this? This is a vector, this is a vector. Both are having ij. How to take the dot product between two vectors having I and j? We know the method. What? I coefficients we multiply plus j coefficients we multiply. Understood? Then what do you get there, people? Here x, here minus 1. X into minus 1 is minus x. Here y and here 1. It's y. Plus multiplication is plus we get, right? X into minus 1 is minus 6. Y into 1 is y. Is equal to 1. Let us take this as number 1. Right. Secondly, people, this vector and this vector, we take the dot product. That answer given as 17. Then, secondly, xi plus yj dot the vector is 4i plus 3j. It is 17. Here also we know how to take the dot product between these two vectors. X into 4, right? 4x plus and plus make plus y into 3, 3y is equal to 17. This is number 2, people. Now we need to find x and y, no? If we know this x and y both, substitute them here and here, we can find this vector. Now to find x and y, we have two simultaneous equations here, 1 and 2. The two unknowns are x and y. Now you have to solve these two simultaneous equations and find x and y. You know how to find this x and y by solving these two simultaneous equations. There's a question in grade 9, no? So you started the simultaneous equations in grade 9, no? Or 10. So by solving these two simultaneous equations, find x and y and substitute those found x and y where? Here and here. Then we get the required vector. Understood? Okay. Right. Then how to solve that one, people? I'll give 2 minutes. Solve that, people. Solve this and find x and y. I can very easily solve this way. First equation, I multiply by 4. That means this and this we have to multiply by 4. And then you can very clearly understand when you multiply this by 4, this will be minus 4x. This is plus 4y is equal to 4. That equation is written like this, and to that equation, I am going to add number 2. Right? So then we are going to do this part mentally without writing more steps. Now when I multiply this by 4, we get minus 4x. That and this 4x we add minus 4x plus 4x. What happens? 4x minus 4x will cancel off. No x term. We multiply this by people 4. Then this is 4y. That time this 3y, when we add, we get 7y. Now come to right hand side. This is multiplied by 4. Then 1 into 4 is 4. Plus this 17 people, it's 21. Then cancelling by 7, we get y is 3. We found y. Put that y we are here. Take this right hand side. Now by 1. Minus 6 plus y is now this 3 equals 1 minus 6, 1 minus 3. This is minus 2. Minus x equals minus 2 means cancelling this minus sign, we get x equals 2. x2 y3. Then putting that here and here, we can find the required vector. Therefore, the required vector. Therefore, the required vector is what, people? 2y plus 3j. This is the vector we need. 2y plus 3j. The vector we need. Right. Okay. Right, people. The next question that we're supposed to do here. Right. Take question of 65. Another simple question. Number 65. Number 65 is another simple question. It is find lambda such that vector A given 2i plus 3j, vector B given lambda I plus 5j. Lambda I plus 5j. What is the question asking, people? Find lambda such that vector A perpendicular to vector B. This vector A is given this way, people. Vector B is given this way. Now this A vector and B vector should be perpendicular to each other. You know, people, we learned among the properties of the vector dot product, when two vectors are perpendicular to each other, the dot product of the two vectors is 0. Understood? We wrote that. When two vectors A and B are perpendicular, then A dot B is 0. I think you can remember that. Okay? Go through the notes. A dot B is 0 when A and B are perpendicular to each other, right? A dot B equals 0. Since A perpendicular, or when A is perpendicular to vector B. This is a notation to say perpendicular. Okay, right. Right. Now substitute for this A, it is 2y plus 3j. Dot, what is B? Lambda I plus 5j. It should be equal to 0, people. Now here in the left hand side, we have two vectors in ij form. How to take dot product? We have to multiply I coefficients. We have to multiply j coefficients, right? 2 into lambda, 2 lambda, plus and plus make plus 3 into 5, 15 is equal to 0. The lambda is minus 15 by 2. Understand? That's how we find the lambda. Right. Okay, people ask the next question. Right. Right now, people, let's see. In this OXY Cartesian coordinate plane, I'm going to consider right. There is a vector that makes an angle alpha. Suppose the vector is OP. Its size is 1. Modulus is 1. That means this OP is a unit vector. Now my question is, how to find this OP vector? How to find this OP vector? Right, I repeat that again. We have a vector OP that makes an angle alpha with the x-axis. And this OP length is 1. Then this OP vector should be a unit vector in the xy plane, making an angle alpha with the x-axis. Now my question is how to find this OP vector in ij form, that means involving I and j. It's a very easy question, people. Now we discussed this thing in the trigonometry lesson. It is this: when we have this a right angle triangle with one angle theta and the hypotenuse, suppose the length is L. Using this L, this adjacent side and this opposite side, we know how to find. People, can you remember that theory? How to find this adjacent side and this opposite side using the hypotenuse L and this angle theta? It is this, no, people, L cos theta, and the opposite side is L sin theta. This is available in that note. If you are unable to understand that here now, first take this and after the class go through that note and understand that. Okay. Then like that, people, if I drop a perpendicular here, where? To the x-axis, this length we can write. This is the hypotenuse 1. This is alpha. Therefore, this is 1 cos alpha. This is 1 sin alpha. 1 cos alpha is just cos alpha. This is 1 sin alpha is sin alpha. If I take this point as, people, m, you can now write OM vector. OM vector you can write OM length multiplied by the unit vector in that direction O to M. In the direction O to M is the positive x direction, unit vector is I. Then we can write OM vector, how, people? Cos alpha times I. Correct, no? A vector is written how? Its modulus multiplied by the unit vector along the direction of the vector. That you know. This M to P vector, we can write M to P direction unit vector is J. m to p length is sine alpha. Therefore, this mp vector you can write, people, sine alpha times j. Sine alpha times j. Right? Okay. Now you can write OP vector. OP vector you can write by using the triangle of vector addition OM vector plus MP vector. OM vector plus MP vector. Then OP vector, OM vector is cos alpha I sin alpha j. Understand, people? Right. Right. Then people will write one subheading like this. Write down like this. Write down the unit vector along the unit vector along the unit vector along a given direction, in OXY plane. In OXY plane. Right, that is the subheading, in OXY plane. Okay. Now we start from new line, people. Write down. Consider the unit vector OP which makes an angle alpha with the x-axis as shown in the diagram below. Right, people, first draw this one. I think these things you could understand. Then obtain this OP. But what is OP, people? Since its size is 1, the unit vector in the direction of OP, right? Therefore, the unit vector required is cos alpha I plus sin alpha j. Okay, right. This way you can obtain that result. Okay, right. Take it, people. I'll explain the method of getting this unit vector very easily. This only you have to consider. Right. Now, you know, here I am going to complete the rectangle for this triangle. This way, if I draw a side, this way, if I draw a side, okay, this is the rectangle. When this is a rectangle, this side and this side are equal. This side and this side are separately equal. Then this side is L sin theta. This side is L cos theta. By this, people, we can understand another simple thing. This thing we again learn in the forces. Now, this way when we have a line with length L and this angle is alpha, then the corresponding length of the rectangle towards the angle is L cos alpha. Here, this coming. The other side, L sin alpha. That means sin theta because this angle is theta. Okay. Therefore, we say towards the angle cos, here, towards the angle cos, other side sin. Then here to take this unit vector in the direction O to P, yeah, to this OP, what is the nearest x-axis? Positive x-axis, yeah. Negative x-axis, it should turn this way, a bigger angle. Right. The nearest x-axis is positive x-axis. Along that direction, the unit vector is I. Then take that I towards this OP. Then I towards the angle we said what? Cos alpha, no? Then I cos alpha. This is coming. Put plus sign to this OP. The nearest y-axis is this positive y-axis. Along that direction, unit vector is J. J, people, once I bring that here, angle is here, alpha, but we turn on the other side this way. Then what is that? J sin alpha. This is coming. Okay. I think you can remember in forces, in physics, of course, we are having that lesson in the applied maths. We'll discuss that in detail. We know, people, when we have a force like this, if I think most of you have done this in physics, the component of this F to a given direction making an angle alpha, it is F cos alpha. In the other direction, it is F sin alpha. The same way, people. Bring this I onto this OP. Then we get I cos alpha. Right? And bring this J onto this P. Here we don't have angle alpha. Then this is J sin alpha. Right? Just take this one. Don't take seriously. Because I have to do another one question. That's why I am doing this one. Right. So now, using that, people, suppose we have one unit vector like this. That unit vector is this way, people. That makes an angle beta with the negative y-axis. The unit vector is J, no? Now my question is, along this direction, what is the unit vector? Very easy. Right. To this direction, the closest axes are minus y and minus x. Here unit vector is minus I and here minus j. Right. Now bring this minus j towards this direction. Turn this way. Towards the angle only we turn. No? Then what is that? Minus j cos beta. Minus j cos beta. Plus. Bring this minus I towards this. Angle beta here, but here we don't have angle. Therefore, this direction, the component of this minus I is minus I sin beta plus minus I sin beta. Then what is the unit vector on this direction, people? Yeah, it is plus and minus minus, no? Minus sin beta times I minus cos beta times j. This is the unit vector. Right? Okay. At the moment, try to manage this because we discussed this in detail under forces. But I must do one question. That means, you know, in trigonometry, we proved cos alpha minus beta and cos alpha plus beta. That two formulae, people, we can put using the vector dot product. So we need this idea, right? Okay, then shall we write some unit vectors along some given directions in the OXY plane? Right, people? We'll come to one example. We'll do that too. Write down like this as an example. Right, we'll see this way. Write down as an example. This way we have OXY Cartesian coordinate plane. Minus x-axis minus I here. This is minus y-axis minus j. Right. There are 4 unit vectors. This is u1. The angle here alpha. Right. Another unit vector we have. Let us take it as u2 unit vector. This angle is beta. Another unit vector we have, it's u3. This is gamma. Another unit vector we have, this is u4. That makes an angle delta with x-axis. Now my question is, people, to find these 4 unit vectors u1, u2, u3 and u4. Find unit vectors. Right, draw this one, people. Find the unit vectors u1, u2, u3 and u4. These 4 unit vectors we need to find. People, this idea will be very important. Actually, when you work out the question, sometimes that kind of questions you will not be getting via in your term test. But finally, at the end of the syllabus, people, when we do a bigger question, one part of that question will be available, this theory. Okay, at that occasion, if you don't know how to write this on, people, you will find inconvenience. All right, so now can you write this u1, u2, u3 and u4 as the way I illustrated here? Yeah, I'll give you 2 minutes, people, write down them, the 4 unit vectors. Right, what is, people, u1? Yeah, this axis and this axis you have to take. Then the angle is with this j. Then j cos alpha. J cos alpha. J cos alpha means cos alpha times j. That is positive sign. And here I alpha is here, but there is no angle here. Then I, when I bring onto this u1, I, what is that, people? I sin alpha. I sin alpha means sin alpha times I. This is what we get. How to write this u2? All right, u2 unit vector. What are the 2 axes? We have to take this axis and this axis, right? Then the other close axis. Then minus I towards the angle cos beta. Minus I cos beta. Minus I cos beta means minus cos beta times I. This unit vector plus this direction. Bring this to this side. Here we don't have angle. Then once you bring this way, it is sine. J sine beta. Sine beta times j. Okay. How to write u3, people? What are the 2 axes we have to consider? This axis and this axis. But unit vector minus I. Here minus j. Right. So now gamma is with this minus j. Then minus j cos gamma. minus j cos gamma towards the angle, no? Cos. The other sine. Minus j cos gamma. Minus j cos gamma means minus cos gamma times j. Right. And here, minus psi. Here we don't have an angle, but angle here. Then what is that? Minus psi sine gamma. Minus psi sine gamma. Sine gamma times psi. We'll come to you four people. This axis and this axis we need. What is that? I towards the angle delta. I cos delta. I cos delta means what? Cos delta I. And here, what? Minus j sine delta. Minus j sine delta. That means minus sine delta times j. These are the unit vectors. People, at the moment, if you get a particular sort of confusion of getting this, don't worry. Just remember this one at the moment to work out the next question. We will discuss this under cooperative forces lesson again. Okay. The cooperative forces lesson also, people, will be available these vectors. Okay. That occasion, this knowledge is very important to do some questions, right? Some teachers, they can skip without doing this one, because why? In order to teach and in explaining these things, people little bit they find little bit inconvenience. Then the best thing is skipping those kind of questions without doing and skipping the lesson. But one occasion in the syllabus, if you try to do all types of questions available in past papers and some other questions, right? People, this knowledge is very important, right? But the student, they don't know this extent in the syllabus, right? So you are helpless students, no, in the sense, of course, you don't know anything. That's why you are getting some help by teachers. The teacher should have the responsibility to do everything, but that is not always true, right? So therefore, in some other classes, these things are not doing. Then once you compare your note and the other notes, sometimes you might get unnecessary things has been done. That's at the moment like that you get, people, but in the future, when you work out questions, you will find the advantage of knowing these things. Yeah. Right. Now, using this knowledge, people, we can do question number 86 in the tute. Right? Question number 86 in the tute. Right? Now, after doing this question, number 86, people, we are going to prove really this cos A minus B and cos A plus B formulae. Right? That we did in trigonometry. That two formulae we are going to do using the vectors now. Right? Now, if somebody is boasting that we have completely finished what vectors and everything, right? Are you still doing vectors in your class? Then for such guys, you can give this question, asking to prove this one by using vectors. Nobody can prove this one without knowing this theory, people, right? Okay, so situation is like that, right? Let's see how to prove this one, right? Okay, take question number 86. Take question number 86. Right, take your tutorial, people, using vector dot product, prove that. Using vector dot product, prove that. Cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. Yeah, I take this way, this proof. Question number 86. You know cos A minus B formula. That formula only asks you to prove. Cos A minus B formula is, people, it is cos A cos B plus Sin A, sin B. Okay, right. Now to prove this in terms of alpha beta, that means for A and B we have alpha and beta angles respectively, right? I take this way, x-axis with unit vector simple I, y-axis with unit vector simple j people. Then I take this way an alpha angle, this way, OP a unit vector along this direction. Another we take this way Q, it also unit vector making this angle beta. This is alpha. This angle is alpha. This is beta, right? Right. Now, if this OP and this OQ are two unit vectors, we can write them. We can write them. Okay. This OP vector, people have to write. OP vector now unit vector. First, listen to me, right? OP vector is unit vector. How to write OP vector? Yeah, this angle is alpha, I cos alpha plus j sin alpha. No, I cos alpha means cos alpha times I, j sin alpha, sin alpha times j. OQ vector you can write. It is I cos beta plus j sin beta. I cos beta times I plus j sin beta times j. Right. Now what we do, people, I take the dot product between the vectors OP and OQ. I take the dot product between the vectors OP and OQ. OP vector dot OQ vector. People, how to define this OP dot OQ? Apply the definition of the dot product. OP vector modulus multiplied by OQ vector modulus multiplied by cos the angle between OP and OQ. People, this whole angle is alpha, this angle is beta. Then what is the angle between this OP and OQ? It is alpha minus beta. Alpha minus beta. Then we must write OP vector modulus into OQ vector modulus into cos alpha minus beta. Okay. We substitute for this OP and this OQ. Now OP vector is what, people? Cos alpha I plus sin alpha j dot OQ vector is what? Cos beta I plus sin beta j. Right. What is this, people? OP vector modulus. OP vector is a unit vector, people. It is 1 multiplied by OQ vector, also unit vector, multiplied by cos alpha minus beta. Now you know how to simplify here. Dot product between these two brackets. In brackets we have two vectors having I and j. Then how to multiply? We have to multiply I coefficients. Cos alpha, cos beta. Here plus and this plus j coefficients product. Sin alpha, sin beta. On the right hand side, people, cos alpha minus beta. This equals, this means, people, cos alpha minus beta is equal to this. This gives us the first answer. Cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. This way we get, people. This way we get first one. Right? Then write like this. Write down like this. Write down, consider two unit vectors consider two unit vectors OP vector, put an arrow, OP vector and OQ vector as shown in the diagram below. As shown in the diagram below. Let me draw this diagram and obtain the result. Obtain the result, people. Take the answer. Cos L plus beta formula. Right. We move to the second one, people. We move to the second one. Now, for the second one, the diagram should be changed as this way. Right? Now, I think you have completed this. The diagram should be changed like this to get the second one. I take the OQ unit vector. I take the OQ unit vector like this. OP unit vector is still the same like this alpha, making angle alpha. And OQ unit vector, people, I take like this. This way I take. This angle I take as beta. But people, since this angle is rotating clockwise, this should be minus beta. You know, this OXY plane means what? Plane of quadrants, no? Under trigonometry we learned. Then this O, this is Q, this also unit vector. That means the length of Q is 1. This angle is minus beta now. The reason is, people, this angle has been measured starting from x-axis to the clockwise. Then this time OP unit vector is still the same vector as before. What is that? I cos alpha plus j sin alpha. Cos alpha I plus sin alpha j. Can someone tell me what is the OQ vector? I towards the angle cos minus beta. I towards the angle we said cos, no, but the angle is minus beta. I cos minus beta. Here we have to have I write that we are here plus. This time the unit vector from y-axis you have to take this, it is minus j, because this is closer to this minus y-axis. Then minus j, but sine what angle? Minus beta. Then minus j sine minus beta is the unit vector. Now what do you get here? What is people cos minus beta? Cos minus beta is cos beta. We said what? Inside the cos, if we have negative angle, this negative sign we can ignore and we can write that as cos minus theta as cos theta we can write. We know that. Then here cos minus beta is cos beta. Cos beta I. And you know, people, when we have sine and minus angle, sine minus theta, sine minus theta, from this minus sign, since the ratio, trigonometric ratio is sine here, this minus sign you can take out. Sine minus theta is minus sine theta. Then we can write, taking this minus sign out. Once you take this minus sign here, that minus and this minus make plus people. Then we get what people? Sine beta now here, j. Sine beta j. Then this is OQ vector. Now we take people as before, OP vector dot OQ vector. Right? Now tell me, when I write OP vector dot OQ vector, OP vector modulus times OQ vector modulus, actually people, what should be this angle now? Here we take the vector dot product between OP vector and OQ vector now. Then this is the angle we need. This angle is alpha. This angle, people, minus beta. This minus sign coming with this angle because this angle is measured from x-axis to the clockwise. That's the reason why we get this minus sign. What is the full size of this angle? This is beta, people. This is beta. This is alpha. Then what is the whole angle between OP and OQ? Alpha plus beta now. The angle between OP and OQ is alpha plus beta. That angle beta has negative sign because of that has been measured in clockwise direction. That's the reason. Understood? So therefore, this angle cos alpha plus beta. Right? Here we have to have alpha plus beta. Now here OP is the same vector, but OQ vector is, people, what? Cos beta plus sine beta. No? What do you get there? Minus j sine minus beta. Right. Now substitute them there, people, and try to get this answer. Wait, people, here I made a mistake. I made a mistake here. No, this angle minus beta correct. This angle minus beta correct. This measure in this direction. That minus beta correct, people. But this minus sign is not important in this case to write for the unit vector because we take this minus j and this I. Right? So wait for a while. That is not important in this case. The reason is, people, that L cos alpha and L sin alpha case, this is alpha, this is L, no, L cos alpha, and this is L sin alpha, no, right? So whatever this angle, it should be in a what triangle. That angle, of course, people, we consider as positive angle, right? So that one, when you compare here, people, the minus sign, that's true, but this minus sign we can ignore because really this theory we apply here. So therefore, reject this minus sign. We just write cos beta because we take, people, this relevant what? This relevant axis, right? So then this is also not important in that case. This angle is not important, but here we need. Wait, that's correct. Because now this is what, people? Cos beta. I plus and minus make minus sine beta j. The reason is, I can again explain, in that unit vectors, when we find, people, we had been actually we had unit vector like this, make it an angle beta, make it an angle beta like this, some angle we had in the previous example. There the direction of rotation is not important. Okay, not important in this case. Right. This is we take now. Now I put that here, minus sign, and then do this thing, then you get this answer. Second one. That minus sign of the angle beta don't consider, though we rotate that one clockwise, right? Because this direction is not important. We take the signs of this I and j. That's the reason, right? Now here minus j sine beta coming, right? Earlier we had minus sign here. That we have to ignore. Right. Now in the left hand side, what we have is, people, this. How to multiply this? Cos alpha times cos beta. I coefficients we have to multiply. Plus and minus make minus sine alpha sine beta. Okay, now we get what? Cos alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. This is the cos A plus B formula. This whole angle is equal to L plus beta. Right now, okay. And this is how we prove the cos A plus B and cos A minus B formula. Right. Now, another one we can prove, people. That means in trigonometry, we learned cosine rule. Cosine rule. People, can you remember the cosine rule for a triangle ABC subject to the standard notation? What is the standard notation? At the vertex A, the angle is A. At the vertex B, the angle is B. At the vertex C, the angle is C. The opposite side is simple A of this vertex capital A. The opposite side of vertex B is simple B. This is C. This is a standard notation for triangle ABC. Then what is the cosine rule? Cos A. People now write cos A. Cos A. Can remember we did this cosine rule and some questions also we did. What is cos A? It is B squared plus C squared minus A squared divided by 2BC. This cosine rule, of course, we didn't prove. We did not prove under that lesson. But cosine rule we can prove by using the vector dot product method. Let's see how to do this. That question is available, people, in question number 63, part 2. Right? Prove that in usual notation for any triangle ABC. Take question number 63 as the next. Take question number 63 as the next. Right, cosine rule. Right. For the standard notation means this. Right? Yes. Okay. We can take that. You can write proof of cosine rule. Proof of cosine rule. All right. Proof of cosine rule for the triangle ABC with usual notation like this. Okay, this is A, B, C. This angle is A, this angle is B, this angle is C. This length is simple A, this length is simple B, this length is simple C. Okay. Now, I'm going to take, people, this BC vector as simple A vector. You can take like that because this length is simple A. The length BC is simple A. Then it's convenient to take this BC vector as simple A vector. And this vector, CA vector, I'll take as simple B vector. Its modulus is simple B. This vector I am going to take as simple C vector. Like that I take. That's a standard notation. Right, first flow this. This is a standard notation, right? This length is C, the vector is simple C. This length is A, the vector is simple A. This vector is length is simple B, vector is simple B. Vector is, this length is simple B, vector is a simple B vector, right? Length is simple B length, B units. Right, people, now here, by using the triangle law of vector addition, we can write like this, no? BC, B to C vector, we can write like this. B to C vector is equal to B to A vector plus A to C vector. BC vector is equal to BA vector plus AC vector. Understood, right? Yeah. Now BC vector only, people, we have simple A vector. BA vector, B vector is C, then BA vector is minus C. AC vector, CA vector is B, then AC vector is minus B. This way we have. Then we have A vector is equal to minus C minus B. This way we have. Okay. This way we have. Right. Now what I do is this, people. I take now consider A vector dot A vector. Right. We take the dot product of the vector A with itself, A dot A. A dot A. Right. Then on the right hand side, A dot A is equal to A dot. Here we have to write A dot A now, people. Right. For this A, I substitute A is what? Minus C minus B. No? For this, I substitute minus C minus B. For this A also, people, I substitute minus C minus B. Right? Then I can write A dot A is equal to, this is minus C minus B dot minus C minus B. Right. Now from these two vectors, people, minus sign is common. No, that minus sign you can take out. Here this minus sign also we can take out. Then here we have minus sign, here we have minus sign. Minus minus plus. Now within this bracket, what we have? C plus B vector dot C plus B vector here. And here A dot A mean what, people? It is modulus of A perfect squared. Understood? Modulus of A mean what, people? Modulus of A means this BC length, no? Modulus of A is simple A. Modulus of B is what, people? Modulus of B is simple B length. Modulus of C is simple C length. Right. Now on the right hand side, you can take the distributive law. By using this vector C, we take dot product, this and this both, C dot C. C dot C. Right. And this and this. Here plus, it's plus. C dot B. Okay. And now this B dot C. B dot C. And B dot B plus. Right. People, what is this modulus of A? Modulus of A is simple A length, no? This length, simple A. It is A squared. Right. A squared. What is this, people? C dot C, mod C perfect squared. Here, people, C dot B. C dot B is equal to B dot C, no? So therefore, this is B dot C. This is B dot C plus another B dot C we have. It's like X plus X. X plus X is 2X, no? Like that. B dot C plus B dot C means, people, 2 times B dot C. I write it like this, 2 times B dot C. B dot B, mod B perfect squared. Mod B perfect squared. Right. Mod C is simple C, people. Then C squared here. Here A squared. 2 times B dot C. How to write, people, B dot C? Modulus of B, modulus of C, cos. What is, people, angle? Between B and C angle. Here also, you have to understand something like this. Can you remember at the very beginning of this lesson, when we define dot product between 2 vectors A and B, the angle we took between A and B as this, people. See, what is that angle? The angle is when these 2 arrows are going out from a point. We draw the 2 vectors so that they are going out from a point. The 2 arrows here, this one and this one, they are going out from this point here, this way. When we draw the 2 vectors like that, so that the 2 arrows are going out from a point, that occasion the angle between A and B only we have to take to write the A dot B. So then here A dot B is equal to mod A mod B cos theta. Now suddenly, if you take, people, now we need what? The angle between B and C, no? If you take this as your angle, it's wrong, people. Why? Here from this point, this arrow going out, but this arrow come into the point A. Understand? So we should have the both arrows should go out from this point. That occasion the angle only we have to put. Then, people, we have to, this B vector, if I draw starting from A like this, then this arrow will be here, then the arrows this and this will be going out this way and this way. Therefore, this is the angle we must put, right? It is 180 minus A, people. That angle only we must put where? Here, cos 180 minus A. And mod B perfect square. Mod B means what, people? Mod B means this length. B is this vector, no? Its length is B. It is B squared. Right. Now simplify this, people. A squared equals C squared plus 2. Mod B is simple B. Mod C is simple C. Right. Cos 180 minus A. What is, people, cos 180 minus A? Cos 180 minus A is, people, minus cos A. Minus cos A. Right. This is minus cos A. Minus cos A plus B squared. Then take this to this side, then A squared to right hand side, then subject cos A. Then you get the cosine rule. This is how we prove the cosine rule, by using the vector dot product. Okay, vector dot product. Right. Take that, people. Now you can write A squared is equal to, yeah, bring this plus and minus, make minus, no? Minus 2bc cos A. Take this to this side. Plus 2bc cos A. Take the right hand side. B squared plus C squared. Take this right hand side, minus A squared. Now divide both sides by 2bc. Then what do you get? dividing by 2BC, right? We get people. Cos A is equal to B squared plus C squared minus A squared divided by 2BC. 2BC. Then what is this, people? This is the cosine rule. This is the proof of cosine rule. Right. Right. Now, right, we have another little part that is called as the vector cross product. Vector cross product. Okay. We'll write that also. Then people, the theory will be over. Under this vector cross product, people, only the few theories we have discussed in the syllabus. Vector cross product. Okay. In the syllabus, it is given just to introduce what is meant by vector cross product. But people, I can remember in some term test in Kurnagal area, even though the syllabus available to mention what is really the vector cross product, but in that term test, of course, there were two questions under vectors. One is dot product, other one is by the cross product. Okay. So therefore, I am going to discuss a little bit more under this vector cross product. Okay. Right. Now, write down next the subheading as vector cross product. Vector cross product or vector product. Sometimes it is known as vector product. Heading, write down vector cross product. Vector product. Cross product means vector product. It is called as the vector product. Right. Let's see how to define this. And now suppose people, we have two vectors A and B, right? Yeah, to illustrate this, I'll take an example like this. Yeah, I need a plane. Yeah, I'll take this paper. Right, people, now suppose this is a paper, you can see this is a paper, right? On this paper, I now keep this in horizontal this way. On this paper, people, I am going to draw two lines, right? I draw that two lines like this. One is this, the other one is this. Right now you can see this A vector and B vector. Right. Now see here, I have drawn that. Here, if I say like this, vector A and vector B, two lines anyway, right? Now that plane containing these two vectors, now we have. Then the two vectors, people, you can see, right? This way, two lines. Right. Now the two vectors I am going to draw on this vertical plane like this. These are the two vectors A and B. Right. Now these two vectors like on this horizontal plane. Right. People, now These two vectors lie on this horizontal plane. Two vectors means two line segments. Now, can you imagine a line perpendicular to this plane, perpendicular to this page? A line perpendicular to this page. That means when I place this pen on this page vertically, the paper is horizontal now. Horizontal means parallel to ground. Now this pen is vertical. Okay, the angle between vertical and horizontal is 90. Okay, now that pen I'm going to draw like this. Right? Its direction I take upwards. So then when I place people this way, the pen on this paper, right? Right now, these are the two vectors. I make it horizontal like this. Now I place this pen like this. Now this pen is perpendicular to this whole paper. Therefore, this pen is perpendicular to both A and B, two lines also. What do you say? Now, when we stand on the ground means horizontal plane, people. We stand like this. Now, one occasion, you know the shadow of our shadow coming to the ground. Suppose that line and our body. When we measure the angle between that two, what's the angle? 90. That means as long as we are perpendicular to the ground, people, when we stand vertically on the ground, draw any line on the ground, that line will be perpendicular to us, our body. Such situation only, people, I am going to talk here. Right. Now, this line is perpendicular to both A and B. Now we define, people, the angle between A and B to be theta like this. A and B to be theta. Then we define A cross B. We write this way. This is not the usual multiplication, the same sign, but it is called as cross. Not A multiplied by B vector. That way we don't say A cross B. This is defined, people. Modulus of A times modulus of B times, this time we take sine theta. And simple n vector. What is this simple n vector? Simple n vector, people, is perpendicular to the plane containing these two vectors A and B. There is a unit vector. This direction, there is a unit vector. What is this direction? That direction, people, perpendicular to the plane containing these two vectors this way. Right? And now, if we consider this way, we stand on the ground, we draw two lines so that they are going out from our foot. Now, the two lines are on the ground. Then our body is perpendicular to both lines. Then, people, we are perpendicular. I am perpendicular. The one who stands on the ground, perpendicular to the ground. Now, along our direction, this way, there is a direction now this way. Along this direction, there is a unit vector. That unit vector is, people, this n. Then you can see modulus of A is, people, a real number. Modulus of B is also a real number. For sine theta, we get a real number. So therefore, finally, this three product is, people, real number. But that should be multiplied with this n unit vector. Then the right hand side result is what? A vector. So you can very clearly understand, in this case, A cross B, its answer on the right hand side is a vector. So in this case, people, the result of A cross B is a vector. That is why, people, this is known as a vector product. In dot product, of course, this right hand side answer was a only number. It is a scalar. That is why dot product we said as scalar product. This time the result is a vector. So therefore, the A cross B is sometimes known as people vector product. Okay. And the other thing is people, this n is a unit vector perpendicular to the plane contained in these two vectors A and B. And people, when we consider people perpendicular, you can very clearly understand this book. When I keep parallel to ground, I can keep people this pen on this book. Then this pen is perpendicular. Perpendicular means the angle between the surface of the book and the pen is 90. One direction is upward direction perpendicular. Similarly, people, we can take what? This way downward direction. Therefore, perpendicular to this surface of the book, there are two perpendicular directions. Above, upward direction from the plane, downward direction from the plane. What direction is in? That direction also, people, we define like this. Now, suppose here, the two vectors, right? I am taking again the two vectors like this. Now I draw the two vectors again, people, like this, right? Okay. Suppose this is our vector A and this is vector B. All right. Now the new one I do is this way, people. Now here I keep this way, right? Now A is here, B is here. Now I bring this horizontal like this. Now we consider A cross B, no, people. Now take your right hand. Then you know this way we have an edge. That edge we keep on the first vector line, vector A, no. On this A, I put this edge of my right hand. Then people, you can see your thumb, this finger, thumb, that is pointing to what direction? Up, perpendicular to this plane, up. Along that direction only, people, this in lies. Understand? So that direction is known as, people, you know, if you have this kind of pen, this top of this pen, people, you can rotate here. You can rotate it this way. Once you rotate it, people, you know, this head of this top will be coming upward direction. So that time we say, people, when we rotate like that, this way only we have rotate. It is known as the direction of right-handed screw. Right-handed screw. This way when you rotate, this way here, this way when you rotate, people, this top is coming up. That direction is the direction of this what end. That means like this, people. We keep this edge on the vector A, starting vector A. Then we have to come to what? B, no? A cross B. Keep this edge on A, then turn to this direction. Then you know this thumb is coming. When I keep like this, this is now vertical. A cross B. We turn from A to B. That occasion, people, we rotate this way. Right-handed screw direction. That direction, that occasion, the thumb is coming out. That is the direction of, people, this end. Okay. Then the direction of N is explained like this. When a right-handed screw is turned from A to B, the direction of its head moving to is the direction of this simple N vector. That is how we mathematically explain the direction of this N. Right? Now this vector cross product, people, in nowadays, it was a very large, right, part. This vector cross product, people, you need whenever you learn electrical engineering, electronics, right, magnetism, in physics, in not in else, but in the university, when you learn this cross product is very essential. Everywhere you can see applications of this cross product in electrical, in electronics engineering classes. Understand? But in aeros, people, we learn a little bit, just the introduction. But in nowadays, of course, we had whole part in this lesson. Okay. So then today I supposed to just introduce this what is A cross B, and next day I supposed to do some questions. Okay. Right. So then people write down vector cross product. Right. I'll write down like this. Write down let simple A and simple B, they are vectors. Underline them. Let simple A vector and simple B vector be two vectors such that the angle between them be theta such that theta less than or equal to pi, greater than or equal to 0, greater than or equal to 0. Right. Now people draw this diagram. Right. Now we write people like this. Write down the cross product of the vectors, the cross product of the vectors simple A vector, underline simple A, and simple B vector is denoted by A cross B, by A cross B and it is defined as A cross B equals mod A times mod B times sin theta simple n vector, sin theta simple n vector. I'll write down where simple n vector, simple n vector simple n vector is a unit vector, is a unit vector perpendicular to the plane, perpendicular to the plane containing, perpendicular to the plane containing the two vectors simple A vector and simple B vector. Right? Okay. Now we are going to explain its real direction. How to explain people real direction? We take in this case the story of the right-handed screw. The best example for the right-handed screw is, people, this kind of pen. I think you have seen. Here, this pen, right? So now it stopped, people. We can here rotate. No, this way I am rotating here. Here, this way. Then the top is coming up. That kind of screw only, people, we define as right-handed screw. Yeah. Now we turn this right-handed screw from A to B. Then that its head is coming up. Along that direction, there's a unit vector. That unit vector is this N. To find that only, people, we use our other technique like this. We keep this right hand, this edge on the starting vector A, right? Here, A here. Then we keep this way. Then you can see our thumb is coming perpendicular to this paper out this way. When I turn this horizontal, people, that direction going to be here upward. Then when we turn from A to B, the thumb is pointing to a particular direction. Along that direction is perpendicular to this paper, the surface. Along that direction, there's a unit vector, that is N. That direction only, people, we explain how. When we rotate a right-handed screw from A to B, the direction its head moving to is the direction is of this simple N unit vector. That's how we mathematically explain the direction. Understand? When you actually go through what all books, people, that way it is explained. Right-handed screw. Right? Screw means, now you can understand. Right-handed screw. Okay. Write down like this, people. Write down the exact direction. The exact direction of simple N vector is the direction to which the head of right-handed screw move when it is turned from vector simple A, underline simple A, vector simple A to vector simple B. Vector simple B. Okay. Right. The other sentence, people, the last sentence. This final result is, since we have on the right hand side a vector, the final result is vector. So therefore, A cross B will give another vector. So that is why it is known as a vector product. Right. Write down the result of A cross B. The result of A cross B is a vector. The result of A cross B is a vector. Therefore, cross product is known as vector product. Vector product. Cross product is known as vector product. Right, people? So this is the end of the theories of this lesson.